In this video, we will learn to calculate coefficient of viscosity of a liquid by capillary flow method. First, we will find what is the time of flow of liquid. This table represents the experimental observation recorded. So in the first column we have burette reading for the level of 0, 5, 10, 15 till 50. The next column we have the time of flow of liquid recorded for every 5 cc of the burette level. For the 0 marking of the burette, the time taken is 0. Then for the 5, we have it is 11 seconds, and for 10, 24. As it goes on, for reaching the level of 50 in the burette reading, the time taken is 3 minutes 13 seconds. Our first task is to convert all the minutes into seconds. So in the last column, we have converted everything into total seconds. For 0 level of the burette, it is 0. For 5th level, it is 11. And 10th level, it's 24. For 15, it is 38. For level of 20, it is 53. For 25, so the time recorded is 1 minute 9 seconds. So 1 minute is 60 seconds. So 60 plus 9, 69 seconds. For 30, it is 1 minute 28. In seconds, it is 60 plus 28, it is 88 seconds. In the same way, we can convert every minute into an seconds. For the burette level of 50, the time taken is 3 minutes 13 seconds. When you convert it into seconds, we get 180 plus 13 seconds, it's totally 193 seconds. So we have converted all the time recorded in seconds. Next, we need to find out the value of Ht by V. Here, the capital H is nothing but it is the height at which the capillary tube is from the ground level. So here it is 10 centimeters. In meters, it is 10 into 10 power minus 2 meters. You may get it as a 9 or 8, whatever it is. So from our experimental recording, the height at which the capillary tube is from the ground level, capital H, is 10 into 10 power minus 2 meter. And the capital V, that is the volume of the flow of liquid observed here, is for every 5 cubic centimeters. So it is 5 cc is cubic centimeters. So 5 into cubic in all sides. So it is 10 power minus 6 meter cube. So when we convert it into a cubic centimeter into SI unit, that is in meters, we get 10 power minus 2, the whole power 3 will give you 10 power minus 6 meter cube. So next we have to find out the flow of liquid for a particular range. So here range taken is for every 5 cc, as I have already told you. So 0 to 5, 5 to 10, 10 to 15, for every 5 cc of flow of the liquid, what is the time recorded? So we from the previous table we know for the burette level of 0, it is 0. For the burette level of 5, it is 11. 11 second has taken. So 0 to for flowing for the range of 0 to 5, 11 excuse me 11 seconds has been taken. And similarly from 5 to 10, it is 30 seconds. From the previous table we can see 24 seconds has been taken for the liquid to flow from 0 to 10 level. So it is 24 minus 11, we get 13. So for every 5 cc, for 5 cc range, so 20 to 25, we have to subtract the time taken for 20 and 25. So you will get it as 16. So for the last level 45 to 50, for the you have to subtract the time taken for the 45 and the 50. So the difference will be 34. So then what is this H1 and H2? The height of the burette from ground to the 0 level is 78. and for this level 5 is it is 73. And for the next range, for 5 to 10, the height of the burette from the ground level for the level of 5 is 73. So you can measure it using a meter scale while doing the experiment and record it as H1, H2. For the last 45 to 50, it is 33 to 33. H1 is 33 and H2 is 28. Next, we need to calculate H. The formula to calculate the H goes like this: H1 plus H2 divided by 2 minus H, that is your height of the capillary tube from the ground level. So what you have to do is H1 is 78 plus 73 divided by 2 minus 10. So if you do, you will get 65.5. So 78 plus 73 divided by 2 will give you 75.5, and the H here is 10, so it is 65.5. So for the next set of reading for 5 to 10, the H1 is 73 and H2 is 68. So 73 plus 68 divided by 2 will give 70.5, and the capital H here is 10, so you get 60.5. In the same way, we can calculate till the range of 45 to 50. For the range of 45 to 50, H is 20.5. Next, we need to find out what is Ht by V. So for the level of 0 to 5, for the burette range of 0 to 5, the H is 65.5, and for the time taken for it is 11 seconds. So 65.5 into 10 to the power of minus 2 into time taken is 11. The whole thing has to be divided by our capital V, that is the volume of the flow of the liquid for the level 0 to 5. It is 5 cc. So 5 into 10 power minus 6. So in the numerator we have 10 power minus 2. In the denominator we have 10 power minus 6. So totally, when this 10 power minus 6 goes to the numerator, so 10 power minus 2, 10 power plus 6. So it becomes 10 power 4. So for the first set of reading 0 to 5, H is 65.5 and T is 11. The whole divided by 5, that is V is 5, we get 144.1 into 10 power 4 second per meter square. For the next level, burette range of 5 to 10, the time recorded is, or the time of flow from 5 to 10 is 13 seconds, and the height H is 60.5. So 60.5 multiplied by 13 divided by 5 will give us 157.3. The same way we can calculate for all the burette range. So we will get readings like this. When looking into it, we could see almost the Ht by V is around 150. It is around 150. So in the last two readings, you could see 137.7 and 139.4 deviates from this range. So while taking average, I have taken out these two readings. Leaving these two readings, I have taken average for other readings. So the readings highlighted in violet color or left while taking average, since it is more deviated from the other readings. So I have added all the other 8 readings and divided it by 8. So I got my Ht by V is equal to 149.65 into 10 power 4 second meter square. So we have found Ht by V. Next, we need to find out the radius of the capillary bore or the capillary tube, bore of the capillary tube, which we are using by mercury pellet method. So for that, first what we will do is we will weigh the mass of the empty china dish here, which is taken as M1. Here it is 24.923 into 10 power minus 3 kilogram. Then we will weigh the mass of the china dish plus the mercury pellet taken M2, which is 26.575 into 10 power minus 3 kilogram. So difference of these two readings will give us the mass of the mercury pellet taken in the capillary bore. So M is equal to M2 minus M1. So 26.575 minus 24.923 into 10 power minus 3 kilograms. So the mass of the mercury pellet is 1.652 into 10 power minus 3 kilogram. And the length of the mercury pellet taken in the capillary bore is, or capillary tube is, that is small l, 17.1 centimeters or 17.1 into 10 power minus 2 meters. And the total length of the capillary tube used, capital L, is 33.6 into 10 power minus 2 meters, that is 33.6 centimeters. And for the calculation we need the density of the mercury. It is D, 13,600 kilogram per meter cube. So you can write it as 13.6 into 10 power 3 or in whatever way you feel like. But I am taking it as in 13,600 kilogram per meter cube. Okay, now let us find the value of, R, that is the radius of the capillary bore R. The formula goes like this: R is equal to root of M divided by pi small l d meter. Here M is the mass of the mercury pellet taken in the capillary bore, and pi we know it is a constant. L is the length of the mercury pellet inside the capillary bore, and D is the density of the mercury. So we know the mass of the mercury pellet is 1.652 into 10 power minus 3, and pi is 3.14, and the length of the mercury pellet taken is 17.1 into 10 power minus 2, and the density of the mercury is 13,600. So in the next step what we have done is we have wrote M as such, that is 1.652 into 10 power minus 3 divided by 3.14 into 17.1. This 13,600 has been written as 136 into 10 power 2. So already in L we have one 10 power minus 2, this is 10 plus 2, this 10 power minus 2 and 10 power plus 2 will get cancelled. So we are left with square root of, so everything is under square root. So it is equal to root of 1.652 into 10 power minus 3. And the next step we have multiplied all the denominator values, which comes around 7302.384. Okay, in the next step we are dividing 1.652 divided by 7302.384. So everything is under a square root. So the answer what we will get is root of 2.2622 into 10 power minus 4. It will be in the calculator itself. This 10 power minus 4 will be in the calculator itself. Students, do not miss out this. 10 power minus 4, already a 10 power minus 3 is there, that will come. Okay, in the next step what I am doing is I am pushing this 10 power minus 1 inside. When I push it inside, I will get 0.22622 into 10 power minus 3 into 10 power minus 3. Okay, so now I have to take the square root. When I take the square root for the numbers 0.22622, I will get 0.4756. And I have 2 10 power minus 3 into 10 power minus 3. When I take a square root for this, I will get only 1 10 power minus 3. So the radius of the capillary bore is R equal to 0.4756 into 10 power minus 3 meters. So some may write it as 4.756 into 10 power minus 4 meters in all. But I always keep this in millimeters, that is 0.4756 into 10 power minus 3 meters. Okay, next we will find out eta, that is the coefficient of viscosity of a liquid. See the generally we can find for any liquid, from a low viscous liquid to a high viscous liquid. Mostly in Indian laboratories we use water or kerosene. So these are the available liquids, very easily available liquids here. So all the readings taken here is corresponds to the coefficient of viscosity of the water. So we know pi is 3.14, and since the experimental liquid is water, it is rho equal to 1000 kilogram per meter cube. If in case you take kerosene, the density may be 800 kilogram per meter cube. And g, we know the acceleration due to gravity 9.8 meter per second square. R, that is the radius of the capillary bore, 0.4756 into 10 per minus 3 meters. L, 33.6 into 10 per minus 2 meters. And ht by v, from this previous table we got it as 149.65 into 10 power 4 second per meter square. So I always insist students to write each and every a parameter involved in the formula to write the values on the top with the powers in SI units. So we know SI units, that is meter, kilogram, seconds. So convert everything into meter, kilogram and seconds, then it will be convenient for us to do the calculation. So this is the Poiseuille's formula to calculate the eta, which goes as pi rho g r power 4 divided by 8L into HTV, Newton second per meter square. So let us substitute it. When we substitute, for pi it is 3.14, rho we know it is 1000, g it is 9.8 into the radius of the capillary bore 0.4756 into 10 power minus 3 the whole power 4 into that ht by v, that is 149.65 into 10 power 4 the whole divided by 8 into 33.6 into 10 power minus 2. So in the next step, what is taken is all the powers has been sorted out. So it is 3.14. See, this 1000 has been wrote as in 10 power 3 in the end. So it is 9.8 and then the radius 0.4756. The whole power minus 3 to the power 4 will become 10 power minus 12. The 10 power minus 3 in the radius, when you take to the fourth power, it becomes 10 power minus 12. That is minus 3 into 4 in powers. We will not square it or take cube for it. See, whatever you have, you will just multiply. So 3 into 4, it is 10 power minus 12. Then already we have 10 power 4 from this ht by v, and this 1000 has been wrote as 10 power 3. So the whole divided by 88 into 33.6 into 10 power minus 4. So in the next step, the power in the denominator has been taken to the top, I mean to the numerator. So we got, and the powers has been sorted at the end. So it is 10 power minus 12. Already we have 10 power 4 and 10 power 3. Combinedly it is written as 10 power 7. The 10 power plus 2 comes from the denominator. In the next step, what we do? We multiply everything. When we multiply everything, all the numerator and denominator, we get 235.6131 into 10 power minus 12, and 10 power 7 and 10 power 2 adds up to 10 power 9 divided by 268.8. When you divide the numerator and the denominator, we get 0.865 and the power will be 10 power minus 3. So we got the eta value as 0.8765 into 10 power minus 3. So this is the coefficient of viscosity of the water. We can write it like this, or we can also write it as 8.765 into 10 power minus 4 or 0.0008765 Newton seconds per meter square. In either way you can write from the experimental the exact value obtained through the experimenters for an coefficient of viscosity of water is 0.00082 to 0.001. So we have got an exact value of 0.0008765 Newton seconds per meter square at room temperature. I hope this video will be very helpful while you calculate the coefficient of viscosity of a liquid.